Well, I see that most of you have answered that the amount of charge is 5.4 coulombs. If they're 0.9 coulombs on one, they're 5.4. So how did you get that? What is it that you did? What operation did you do to figure out the amount, 54? And I think that if you think about it, you will say, I multiplied the 0.9, which is on 1 centimeter, by the 6 centimeters. So this is the amount of charge on 1 centimeter. So that is charge per 1 centimeter times the 6 centimeters. So the amount of charge on 1 centimeter times the 6 centimeters gave me the total amount of charge. And as you see, charge per length, so charge per length times length will give me total charge. So this is a mechanism, this thing right here is the means of converting charge to lengths, or in this case, lengths, 6 centimeters, converting lengths to charge. It's like a conversion factor. What it actually is the linear charge density. It tells me the concentration of charge per centimeter of stick. That tells me how dense the stick is. And in particular, for us, the Q per 1 centimeter is 0.9. That's a comma. So 0.9 coulombs per centimeter. Actually, I should give myself a little more room and include the units. So 0.9 coulombs per centimeter. The 0.9 coulombs per centimeter is the concentration of charge on the stick. If I had doubled the charge, in originally charging the stick, if I had put twice as much charge on the stick, all of the charges would be closer together by a factor of 2. If all the charges were closer together by a factor of 2, then in each 1 centimeter would contain 1.8 coulombs, twice as many. So the concentration of charges is given by this number. When this number is 0.9, it says that the charges are sort of spread out. When that number is 1.8, it says that the charges are twice as close together. If that number were 2.7, it said that the charges are 3 times closer together, or more dense. And that is why we call this the linear charge density. So lambda is the total charge per total length. Sorry, I see I have an error in my algebra. Is the total charge per total length. Lambda is the total charge per total length, and I can then find charges on individual pieces as Q for some length is equal to the total charge per length times that length, L. So as a general statement, the amount of charge on some length is the charge per unit length times the length. In particular, and this is the use that we will make for our application, the infinitesimal charge on a very, very short length, dq, is equal to the charge per unit length times the very short length, dy. So this is the same kind of algebra that you use down here. Charge per unit length times length is charge. In this particular case, I want the charge of a very, very short length of my stick, dy. So the charge per unit length, or the infinitesimal, sorry, that's the charge per unit length, the infinitesimal amount of charge dq that sits on a tiny piece of stick dy is tiny piece of length times charge per unit length is tiny piece of charge. So that's going to be able to allow me to substitute instead of dq something that is in terms of dy. Okay, very good. So let's go back to our main problem.